Thank you to all of our speakers today. A round of applause for all the speakers. Thanks, guys, so much for making this conference. That's not right. Let me just put up the slide. We have a couple of options of activities now. Dinner is not going to be ready for another about 15 minutes. We can take a break and get out of this hot room, or if you guys are interested, we can do some Q&A about maybe the old times. We can get Mark to come up here, and we can just take whatever random questions folks have about back in the day of ZFS or future stuff. What do we want to see in ZFS? I'm also told that a special guest may be arriving in like 15 minutes or so who may be able to join us. Are folks too hot to do that in here, or do folks have questions? If there's no questions, oh no, Mark wasn't feeling well. All right, well, sorry, Mark. Then we can have special Q&A time with me, and let's say any other ZFS developers who want to come up here and field questions about. George, why don't you come up here? Well, I don't know. Everybody seems a little hot and tired, so maybe not. If there's no questions, we're going to go take a break because I've been sitting in the hottest part of the room. Yes. So you're asking about like a library to do kind of programmatically control ZFS. Yeah, so in terms of the administrative actions, you can do that with libzfs. The ZFS command, it pretty much just calls into libzfs. But that's an unstable interface, and we've changed it a bunch over time, and it's kind of hard to use programmatically because the error handling it tends to do a lot of things with one function call. Like you do one function call to libzfs, and it does like a whole bunch of stuff, and it might fail somewhere in the middle, and you get some error code. So we created libzfs core, which is like pretty much a thin wrapper layer around the ioctls to the kernel. And the idea is that will become a stable interface with defined error semantics that just does one thing at a time. And it can't do everything that ZFS can do yet, but that's really the future direction, and that's what I would encourage you to take a look at. So libzfs core is upstream. You can use it today. Like I said, it only covers maybe 2/3 of the stuff that you can do with the ZFS command, and I think nothing or very little that you can do with the zpool command. Yeah.
I think there were several companies that at one point in time were making enhancements to libzfs core for like zpool commands, but I don't think any of that work has been upstreamed. So if you're one of those companies, we'd love to see those contributions.
That was Cluster HQ, I think. So if anybody's here from there, ping them. Other random questions? Yeah, Dan.
Tying in with testing, we have Lumos, and I don't know if FreeBSD or Linux has something equivalent. When we run debug kernels in Lumos, we have a bunch of extra things turned on, debugging features that otherwise might not get tested. Things like the kernel memory allocator will check for double freeze and buffer overruns and the sort of stupid memory management things that you might not catch during regular testing, as well as having all the assertions trip off. I just wanted to mention it out loud so people who aren't Lumos natives, like myself, know that if they're testing on Lumos platforms, they should definitely run the debug kernels, if at all possible. Maybe definitely not for performance, but for functionality tests. And they should check, even if it runs smoothly, they should take kernel core dumps afterwards and run MDB's wonderful find these, because it'll find stuff.
Yeah, I guess for the video, basically the comment was that there's a bunch of other system level debugging stuff that is applicable on Lumos, like KMM flags, and it probably makes sense to look for similar kinds of things. Like I know on FreeBSD they have this witness lock order checking, so that would be a good example of things that we would want to turn on like when running the test suite. Okay.
I had a back in the day story that tied into some of the stuff that Mark was discussing. So he mentioned that the kind of the initial hello world for ZFS was going to be this test where they do a big bring over of all of the date command, compile it, and like make sure it works. So have people here played around with something called ZIL test? Are you familiar with something called ZIL test?
Like two people have raised their hands.
Yeah, so there are still remnants of that same type of logic in that test. It actually does try to bring over the date command, run it. Yes. I didn't, to this day, until today, I did not know why they picked date, but I guess it's a carryover from that initial.
That's funny. Is that related to like zpool freeze? That's related to ZIL test, right?
Yes.
That's still.
Yeah, like it's testing
Yeah.
to see like when the ZIL can actually recover as a result of like a panic failure. It's actually a pretty simple test, but if you're doing any kind of ZIL work, well worth kind of playing with it.
Yeah. Sorry, what? Direct IO. So I think that gets a little bit to what Mark was talking about earlier in his talk about like the VFS locking and the idea that we didn't want to replicate that in ZFS. So like direct IO, at least in Solaris/Illumos, the point of direct IO was like to disable this file level locking so that you could have it like a database doing concurrent writes to the same file, to one file, all at the same time. So in ZFS, we didn't want to support direct IO. We wanted to make it like not necessary to have that hack, because we saw direct IO as essentially like a hack because like the locking was so poor. So Mark didn't talk about this, but one of the things that he implemented was the range locking in the ZIL. So when you are doing a write system call, you can get the POSIX semantics of no overlapping writes, but with locking just the range that's being written. So you can still have a whole bunch of writes covering different ranges of the file going on concurrently. So we don't have any plans to add direct IO support. Hopefully there's no need to do that, at least on Lumos. If there's like Linux specific stuff, then maybe we should talk offline. Yeah, so the question was basically there's another mode for bypassing the cache, which I think makes sense. For reads, I think that totally makes sense, where you have a read and you want it to not pollute the cache and to hopefully take a faster IO path. For writes with ZFS, it's a little bit harder because we're normally doing like checksumming and all this other stuff, and putting the IO off until syncing context because we're copy on write. So that would probably be much more difficult, but doing something like that for the read path, I think totally makes sense. I think.